Alright, we have a question here from 2013, question number 2. It's a maximization question again. The frame of the crate is made up of 12 steel rods that have a total length of L centimeters. The length of the crate is twice the width. Show that the length of the crate will be L over 9 centimeters when the volumes are maximum. So here's the question, and let me work through the answer to this. If you like the way that the New Lake textbook does it with the Dell's det, we can go through this. I'll follow the same process, but I won't use those names. Drawing's already done. In terms of getting some equations together, we can see that the length, I'll call the length lowercase l, is equal to 2 times the width. Or in this case, it's 2x. The total length of the whole thing, the length of our wire needed, or steel rods needed, is, well, if you look at all the widths, there's 1, 2, 3, there's 4 x's. In terms of the heights, there's 4 heights as well, so 4 lots of h, which is the height, plus lengths. Well, there's 4 of those, but each of those is worth 2x, so I can put it this way and call that for 12x plus 4h, and that gives me L, the length. So there's one equation. The other equation is the equation for volume. Volume equals length times width times height for a cuboid. In this case here, the length is, well, 2x, we know that already. The width is x, and the height h. Well, it's called h for now. We need to connect these two, and that's where the substitution thing comes from. So we need to connect the two. We also want to make v the subject of only one variable. So I want to make it a subject of x only. So I'll get rid of the h. How do I do that? Well, I go back to this one here, rearrange. We'll end up with 4h is equal to L minus 12x. Divide both sides by 4. We end up with a quarter L minus 3x. So I can replace h with this. 2x times x times what h equals, which is a quarter L minus 3x. And now we notice, apart from L, which is a variable, that's constant. That L is the same the whole time, so we can call that a constant. We've only got x's. Collate them together, 2x squared over, so x squared L, or Lx squared over 2, minus 6x cubed. So that's the volume of the thing with respect to x, a function of x. Alright, whenever you're trying to find a maximum or a minimum, or in fact any stationary point at all, you let y dashed equals 0 and solve. So take the first derivative, make it equal to 0 and solve, and that'll tell you when your gradient function is 0, or in this case when you get up with a maximum or a minimum. So I'm going to go v dash of x, differentiate this. If you prefer, it's dv by dx, means the same thing. Multiply the power out the front, so 2 times L over 2 just gives me L, and reduce the power by 1. I'm not going to put the 1 there. 3 times 6 is 18, x squared. And I'm going to make that equal to 0 and then solve. Lx equals 18x squared. Get it this way. Divide both sides by x, so L equals 18x, or x equals L over 18 is the same thing. So we've done a differentiation, we've equated to 0 and solved. We're up to back substitute. So they're asking to put this back into one of the equations. Sometimes they ask you what is the maximum volume, in which case you'd put this back into here. But they're not asking that, they're finding out what would the width be, sorry, the length be. Now length. Here we go. Here's an equation for length. Length is equal to 2 times the width, or 2 lots of x. So by substituting, we get L is equal to 2 lots of the total length of all the steel rods divided by 18, which equals L over 9, which is what we're asked to show. job done.